Chain, chain, chain. Chain rule. Chain, chain, chain. Chain rule. You'll get the full song afterwards. All right, this is the chain rule. This is one of the big rules. It's almost as big as the power rule. And the reason it's almost as important as the power rule is because it's an extension of the power rule. So here's the chain rule. If you try to read this and make sense of it, it looks like total Chinese. I mean, no chance here. All right, it's actually a fairly easy rule. Let's look down at an example before we go to that. Here's when you're going to use the chain rule. It's when you have a composition of functions. So you have 3x squared minus 4x has been plugged into another function that was x to the third. So you have a function inside of a function. Now look back up here. This bottom part actually makes some sense. If you want to do the derivative, change with respect to x, a derivative with respect to x. You want to do a derivative, and you have a function inside of another function. Here's how you do it. You do the derivative of the outer function. F would be our outer function. You do the derivative of the outer function. Okay, you leave the inner function alone, times the derivative of the inner function. And it's actually an extension of the power rule. You'll see that as we go. All right, so let's go ahead and do some examples, and this will make a lot more sense for you. Let's go to example 1a. All right, so we've got to find the derivative of this equation. So I'm going to write f prime of x equals, and to do the derivative, my outer function is all of this stuff in the parentheses to the third power. So I'm just going to do the power rule to that part. So I'm going to bring my 3 down in front, 3 times all that stuff that's in parentheses. And then I got to drop the 3 1 degree. So now it's squared. And then since the stuff inside of the parentheses can also have a derivative, that's what the chain rule tells you. You have to do times the derivative of the inside. So I've done the derivative of the outer function, and then I'm just going to multiply by the derivative of this inner function right here. So 2 times 3 is going to give me 6. Drop it a degree, x to the first, and then my minus 4x, the derivative of that is minus 4. I'm done. That's it. That's the chain rule. And I can clean this up a little bit. Like if you wanted to distribute this 3 to the 6x minus 4, you can do that. I mean, I'm just going to leave it right there. That's it. All they asked me to do was find the derivative. It didn't say simplify or anything. So I'm just done right there. But that's the chain rule. So I say the chain rule like this to myself. Derivative of the outer function times derivative of the inner function. That's the way I say the chain rule to myself. All right, so let's go ahead and go to B. This one is much harder here because we have all of this stuff inside to the second power. So I got the chain rule as my overall rule, but inside of the chain rule, I'm going to have to use the quotient rule. Oh boy. That's when these get complicated. That's when this turns into AP calculus stuff, is when you have derivative rules inside of derivative rules. Okay, so let's go ahead and do k prime of x. And I'm sure I probably don't have enough room to squeeze this in, but we'll try. All right, so I'm going to take the 2. I'm doing the power rule. 2 out in front times all this stuff that's in here. Minus 4 over x squared plus 3, just leaving all the stuff that's in the parentheses. And that goes to the first power now. Okay? I just did the power rule to the whole function, to the outer function. All right, and then that is times the derivative of the inner function. Here's where I got to use the quotient rule. Low d high minus high d low, square the bottom, and away we go. So low d high times x squared plus 3, d high, the derivative of the top is just 3, minus high d low. So the high is 3x minus 4, and I'm just going to go up the page here. 3x minus 4, And then that is times the derivative of the bottom, which is just 2x. All right, and then all I have to do is simplify this. So I am going to go ahead and clean this up a little bit, especially since it went way up here. Now be careful on this. I would add a second set of parentheses or a bracket because it is the derivative of the outer part times all of this. So you better put a set of brackets there so you know if you could work this out, you would have to distribute it into there. Okay, I'm just going to clean up the part in the brackets. I'm not going to clean up a ton of this, just so you can see it a little better. So I've got 2 times all of this stuff in the parentheses, and that is to the first power, so I don't even need to write to the first power. And I've got a 3x squared. I'm going to distribute my 3 here. I'm going to get a minus 6x squared out of this when I distribute to 2x. So I got 3x squared minus 6x squared is going to give me negative 3x squared. I'm going to get a plus 9 out of this, and I'm going to get a minus 8x out of that part. So I can clean it up that much without doing a whole lot of work, so I might as well do that. And again, if you wanted to take the 2 and distribute it to these 3, that'd be pretty easy to do as well. There's really no telling where exactly you should stop on this. That's why the AP Calc exam does not make you simplify. So if I were doing this on the AP Calc exam, I would have stopped right there and said, there's my answer. I would not have even tried to simplify anything because I might make a little tiny algebra mistake in my simplification process. So why risk it? If you don't have to simplify, don't simplify. You need to be able to simplify because part of the AP Calc exam is multiple choice, and they will simplify on a lot of their multiple choice questions. All right, let's get to this last one. Extend my screen a little bit here. Do this. There we go. Okay. All right, so the last question here is find the instantaneous rate of change. As soon as you see instantaneous rate of change or find the rate of change at one point, boom, derivative. So find the instantaneous rate of change. That means do the derivative at x equals 10 for h of x equals this right here. Now, when you look at this, at first you're probably saying, well, wait, this, I don't see the chain rule here. Well, you got the first thing you want to do is rewrite h of x as 3x squared minus 2x plus 40 to the power of 1/2. Now you see the chain rule. Okay? So I have my quadratic plugged into a square root function. I have a function inside of a function. That's how I know it's the chain rule. All right, so I'm going to start doing my derivative because I need the derivative equation so I can find the instantaneous rate of change at 10. So I'm going to go ahead and take the 1/2, move it down in front, keep all this stuff that's in the inner inside function, I guess I'll call it, because I'm doing the outer function right now. And I got to drop this a degree, so it become negative 1/2. I'm just dropping it 1 degree. All right, and then this would be multiplied by the derivative of the inside function. So the derivative of 3x squared is 6x, and minus 2x is minus 2. And bam, there's my derivative. And as far as if I should simplify this, I would not. I would go ahead and just do h derivative of 10. So go ahead and plug 10 in for all those x's and push a bunch of buttons on your calculator. I'm not even going to work it out because I don't want to waste your time. But it would look like this in your calculator. So you can push a bunch of buttons on your calculator. I'll let you do that. There's all the commands that I would put in there. So you'd have to work that out, and you would have the instantaneous rate of change at x equals 10. So whatever that comes out to, yeah, that would be my answer. Okay. So that's it for the chain rule. It's actually, like I said, it's an extension of the power rule, so I don't think you guys will struggle with this. This is your last notes page, baby. School's out for summer. All right, so you guys, this is your last notes page. Mrs. Pinion is working on a Google form for this right now, and she'll release that tomorrow. Thursday will be your last assignment, so it's been a pleasure. And I got one more little video I'm going to shoot just for my classes, so you guys can watch it. Take care.